We all know that the sun is enormous. Its diameter is approximately 865,000 miles, 1.4 million kilometers. But did you know it will get even bigger and brighter one day? That is right. Our sun has a finite lifespan, and at some point in the future, it will reach its terrifyingly large size. However, what exactly does this mean for us? How big will it be? Moreover, how long do we have until this red giant stage of its life hits? In this video, we will answer these questions as we dive into the terrifying size our sun will reach one day. The sun will have 256 times its current size when it's a fully developed red giant, which will happen in about 7.59 billion years. Curiosity, the newly created habitable zone, will extend well into the Kuiper Belt, from 49.4 AU to 71.4 AU. Thus, even though Earth will no longer exist, our solar system may contain many new habitable moons. Time will tell. Please give this video a thumbs up and subscribe to this channel for more stuff before we continue. To sign up for new video alerts, click the bell icon. Have you already implemented it? Let us move on. Some scientists predict that the current stage of the sun's life cycle will end as soon as 5 billion years from now, even though the full depth of the sun is still trillions of years away. The vast star at our solar system's core will have consumed most of its hydrogen core by that time. The sun, as we currently know, will have effectively died. The sun will then develop into a red giant. Nuclear fusion-based heat production will stop. Around this time, the core, according to NASA, will become unstable and contract. The sun's outer layers will grow once the core becomes unstable. That expansion will eventually absorb Mercury and Venus. The Earth will also be battered by the sun's ferocious solar winds, which will strip the planet of the magnetic field that creates its atmosphere. It's unsettling to consider the possibility of any human or otherwise life remaining all those years from now. Of course, before that occurs, the sun poses several other threats. The sun is the largest object in our solar system. The sun's volume would need 1.3 million Earths to fill it. Most giant planets and minor pieces of debris are all in orbit around it thanks to its gravity, which also holds the solar system together. The sun's core is the hottest region, with temperatures that exceed 27 million degrees Fahrenheit, 15 million degrees Celsius. The sun influences the nature of space throughout the solar system through its powerful eruptions and a continuous stream of charged particles. Despite being the hub of our solar system and crucial to our existence, the sun is only an average-sized star. There have been found stars up to 100 times larger. Additionally, many solar systems contain multiple stars. Scientists can learn more about the workings of far-off stars by studying our sun. Our sun is a medium-sized star with a radius of about 435,000 miles, 700,000 kilometers. Although many stars are much larger, the sun is significantly more massive than Earth. It would take more than 330,000 Earths to match the sun's mass and 1.3 million Earths to fill the sun's volume. About 93 million miles, 150 million kilometers, separate Earth and the sun. The solar nebula, a massive spinning cloud of gas and dust, is where the sun formed about 4.6 billion years ago. The nebula spun faster and flattened into a disk as it descended into its gravity. Most of the nebula's material was drawn toward the center to create our sun, which makes up 99.8% of the mass of our solar system. The planets and other objects that now orbit the sun were formed mainly from the material that was left over. The early solar wind of the newborn sun carried the remaining gas and dust away. Our sun will eventually run out of energy, just like all stars. The sun will grow into a giant red star when it begins to die, becoming so big that it will likely swallow up Earth along with Venus and Mercury. The sun, according to scientists, is about halfway through its life and has about 5 billion years left before it turns into a white dwarf. The sun is currently about halfway through its life. It has already burned through most of the hydrogen in its core and is starting to fuse helium. This process is slowly increasing the sun's size, eventually leading to its death. The sun will shine 10% brighter than it does now in 1.1 billion years. The Earth's atmosphere will absorb more energy due to its increase in luminosity. This will start a greenhouse runaway effect similar to the one that made Venus into an awful hothouse it is today. The sun will be 40% brighter than it is now in 3.5 billion years, resulting in the oceans boiling. the ice caps melting permanently, and the loss of all atmospheric water vapor to space. The Earth will ultimately change into another hot, dry world, much like Venus, because life as we know it will be unable to survive anywhere on the surface. The Sun will enter the so-called red giant phase of its evolution in 5.4 billion years. When the core's hydrogen supply runs out, the inert helium ash accumulated there will become unstable and collapse under its weight. This is when the process will start. The core will heat up and become denser, expanding the Sun's size. It's predicted that eventually the Sun will grow big enough to engulf Mercury, Venus, and perhaps even the Earth's orbits. The intense heat of this red sun would scorch our planet and make it impossible for life to survive, even if the Earth were to survive being consumed. However, astronomers have noted that the planet's orbit will also change as the Sun enlarges. The Sun will lose considerable mass through solid stellar winds when it reaches this late stage in its evolution. As it expands, it loses mass, which sends the planet spiraling outward. The question then becomes, will the Sun's expansion catch up to the planet spiraling outward, or will Earth and perhaps even Venus manage to elude it? Schroeder and Smith predict the Sun will rapidly lose mass when it evolves into a red giant star in 7.59 billion years. It will only be down to 67% of its current mass when it reaches its largest radius, 256 times its current size. When the Sun eventually starts to grow, it will do so quickly, traversing the inner solar system in just 5 million years. It will then enter a relatively short, 130 million years phase of burning helium, expanding past Mercury's orbit and then Venus's orbit. It will be losing 4.9 by 1,020 tons of mass each year by the time it reaches Earth, 8% of the mass of the Earth. Over time, the Sun will continue to grow larger and larger. As it does, its gravitational pull will increase, and the planets in our solar system will pull closer to the Sun. Eventually, the Sun will become so large that it will consume Mercury, Venus, and Earth. The consequences of this expansion are genuinely terrifying. The size of our Sun is fascinating and frightening at the same time. We can bask in its immense warmth due to its current size, but it will eventually become much worse, significant, and hotter than it already is. It's difficult to imagine a future where our planet struggles to survive under the intense heat of an ever-expanding Sun and what other changes this might bring about on the Earth. Until that day, we can all be thankful for living in such a hospitable environment with an average star like ours supplying us with energy and light. The video for today is over. If you liked the video, please subscribe to the channel and give it a thumbs up. Remember to click the bell icon to get alerts when new videos are posted. Until then, bye. I will see you in the next video.